Hello students, today we will start our fourth experiment, and the aim of the experiment is to study and practice of connection and reverse the direction of rotation of single phase induction motor. The apparatus required for these experiments are: name of the equipment are single phase induction motor. Its specification is single phase 220 volt 50 cycles per second having 6.5 ampere at a speed of 1500 rpm. So its quantity required is 1. We will require connecting probes, connecting wires, whichever is convenient to you. You can use with 2.5 square copper. Now we will also require a spanner with a wire cutter. Now the theory. The single phase induction motor are not self starting. To overcome this drawback and make the motor self starting, it is temporarily converted into two phase motor during starting period. For this purpose, the stator of a single phase motor is provided with an extra winding known as starting or auxiliary winding. In addition to the main or running winding, the two windings are spaced 90° electrically apart and are connected in parallel across the single phase supply. So students, as you might have already know from your theory classes, that for a single phase induction motor, if we will make the single phase motor excited, it will never start by its own. So we have to convert this single phase into a two phase or multi phase, or also we can make this motor start by applying an external force so as to just start the motor, and after it gains some speed it can rotate by its own. So in a single phase motor will never be started by its own. So now in this experiment it is so arranged that the phase difference between the currents in the stator winding is large, that is ideally 90°. It's not perfectly 90 but close to 90°. Hence the motor behaves like a two phase difference between the circuits can be created. So the motor now behaves like a two phase motor, and the difference between the currents can be created. In split phase machine, the main winding has low resistance but high reactance. So you have to remember this main winding is having low resistance but high reactance. It is just opposite in case of your auxiliary or starting winding, which has high resistance but low reactance. So let me just point it out so that it will be easier for you to understand. Now, the resistance of starting winding may be increased either by connecting a high resistance R in series or by choosing a high resistance fine copper wire of for winding purpose. Hence, current drawn I by the starting winding lags the applied voltage B by a small angle, whereas current taken by the main windings lags B by a very large angle. Phase angle between them is made as large as possible because the starting torque, actually it is starting, it has been written as stalling, no? It is the starting torque. The stat Now the starting torque uh, lags behind the applied voltage V by a small angle, whereas current taken by the main winding lags behind V by a very large angle. Phase angle between them is made as large as possible because the starting torque of a split phase motor is proportional to sine alpha. Actually, students, here it has been misprinted that stalling torque, actually it will be starting torque. So please correct it yourself. So a centrifugal switch S is connected in series with the starting winding and is located inside the motor. Its function is to automatically disconnect the starting winding from the supply when the motor has reached 70 to 80% of its full load speed. Now, this was the theory part. By understanding this theory, we can understand why these motors can be and how the motors can be rotated. But importantly, in this experiment, we have to understand how to rotate this motor in the reverse direction. So to make this motor run in opposite direction, we have to change the direction of flux in any of the two windings, that is starting winding or the running winding. So this is the starting winding, this one is your running winding. So by changing the direction of current of either of the starting winding or running winding, we can make the motor to run in the opposite direction. So by this, connection diagram, you can see there is a switch which can be operated either to position 1 or to position number 2. So by connecting to position 1, which is this one, by connecting to position number 2, we have or we can change the direction of current, and after changing the direction of the current, the direction of rotation of such kind of motors can be changed. So now we'll discuss the procedure part for this experiment. So in the procedure, I have written in brief, you have to write in past tense. So let us discuss what are the steps involved in running this motor and reversing its direction. First of all, connect the two-way switch as per the given figure. If you do not have this switch, then you have to change the switch manually. You have to stop the motor, then you have to change the switch. After changing the switch, you have again to again make or you have to excite the motor, then it can be operated. So if at all you do not have a changeover switch or a two-way switch, now start the motor and monitor its direction of rotation. Now when we will start this motor, we will also monitor the direction of rotation. For the instance, let us assume the motor first starts in clockwise direction. Then we will note the direction of rotation and will stop the motor, and again we will change the connection or change the position of the switch from 1 to 2. Then what we will find that the direction of the current should be changed, and according to our theory part, the rotation should be changed. Now let us perform the or procedure. Let us continue with the procedure. What do we find? Now change the connection as to reverse the direction of current in the starting or running winding. Now start the motor and monitor its direction of rotation. So you will find after starting the motor that the direction of rotation is in just the reverse of the previous case. So in the previous case, we have assumed that the motor was rotating in clockwise direction. So now you will find the motor will now be rotating in anti-clockwise direction. So this was the experiment, and you will draw a conclusion, suitable conclusion, students, because in this experiment you do not have any observation, just you have to observe the direction of rotation. So you can also add observation, writing that the motor was connected and was found to rotate in, suppose someone will write clockwise, some may also write anti-clockwise direction initially. After reversing the direction of current in the stator or field winding, or you can say the starting or running winding, the direction of rotation was changed. Now you will also have to answer this review questions. How the direction of rotation of a single phase induction motor can be reversed. What is the working of starting winding? What is the function of centrifugal switch? What are the winding present in a single phase induction motor? What is the function of a capacitor in a single phase induction motor? So these are the review questions, and a video will be followed by this video. I mean, after the completion of this video, I have sent you a video where you can see the circuit diagram, and also the practicals has been also made so as to easy understanding for you. So go through the video, make the notes, and submit the same in the coming week, or latest by the coming week. So I hope you have understood the experiment. Try to just watch the video, and the connection diagram also is shown in that video. So thank you for watching, students.